Hello everyone and welcome today to the second day of DotVVM Virtual Conference. My name is Andrei. I'm one of the core developers for the DotVVM project, and today I'll be presenting to you two presentations, after which there will be also a couple of other speakers, so there is a lot to be looking forward to. So let's jump straight into my first presentation. In this presentation, I'll be talking to you about a couple of interesting changes that we did in the recent versions of .vvm. More specifically, we will be looking at code analysis features and what tools do we use in the .vvm ecosystem that you can take advantage of when developing .vvm applications, so that you can get faster feedback about your application development process and some possible issues that may be discovered by our tooling. Then we will be talking about JavaScript translations. What are they? What do we use them in .vvm? And how you can take advantage of them when basically extending our data binding system. And lastly, in this first presentation, we'll be talking about view models, supported types in view models, how this was extended, and collections in view models, and what operations you can basically use when working with these data types. So let's start with code analysis. So what tools for code analysis do we have in .vvm? So I'm pretty sure that all .vvm developers are probably aware of our .vvm Visual Studio extension, which is a really powerful tool. And in .vvm 4.0, we actually introduced another tool which can be quite helpful when developing for .vvm. So let's take a look first at our .vvm Visual Studio extension to just get a brief overview of what I'm talking about. So .vvm Visual Studio extension is a pretty powerful tool that and one of its main features is that it assists you when working with our custom file formats such as .html or .control and similar stuff like that. So it's a tool that offers you IntelliSense, syntax highlighting, auto-completion, and all of these nice, really powerful and advanced features that you can use when developing your .vvm applications. However, it is also capable of basically searching for and notifying you of many possible issues that can be discovered right as you type your application. So, for example, in the example that I'm showing here on the slide below, you can see that user is trying to bind within a value binding to a property called title, which is a string property inside a view model, and then by mistake attempted to actually bind to one of its properties called ABC. And as we all know, string doesn't have a property called ABC, and this is something that Visual Studio extension for .vvm is actually can discover pretty fast, because as you are typing your bindings, it's actually being compiled directly using the Roslyn, so you get these very nice exceptions, warnings that that string does not contain a definition for ABC, and there are no accessible extension methods, nor is it a valid property. And this is just a really simple example, but just to get the general idea, whenever working with .vvm Visual Studio extension, it's capable of discovering many issues within your .html, .control, and similar files just as you write them. And we wanted to achieve something similar also in the C# part of stuff. And that's why in DotVVM 4.0, we introduced a new feature called Roslyn Analyzers, where Roslyn Analyzers is a pretty exciting technology that's basically a static code analysis framework built on top of Roslyn, as the name suggests, that can be used to analyze code written in C# and Visual Basic.NET. And what are we basically using Roslyn Analyzers for? We are trying to discover some issues and common pitfalls which we want to be able to issue warnings for as soon as possible. So as you are writing your code, we want to discover as many potential issues as possible and let you know using your common IDE by issuing warnings. So for example, if you are using Visual Studio and you reference DotVVM 4.0 or newer in your application, you should automatically get these DotVVM analyzers registered for you under dependencies and analyzers. This should be automatic. You don't really need to do anything in order to get this feature. Just reference .vvm 4.0 or newer, and this is basically not really only tied to Visual Studio. You can use it basically in any other modern IDE of your choice. So for example, Rider or something similar, not only Visual Studio. And just to give you an example of what we can achieve using these Roslyn analyzers, I've prepared some small examples. So first thing, which is pretty powerful, what we can do is basically perform a really comprehensive serializability analysis of your view models. So we can basically pretty easily distinguish whether you are writing a view model or not, because all view models, as we know, need to basically inherit from an existing view model or just implement our .vvm interface. So what we do, we basically find all your view models and then go over it in visual properties. And whenever we encounter a property, we basically perform a serializability analysis. Is this property serializable? Is it supported by .vvm? Because as we all know, view models in .vvm need to be JSON serializable. There are also some other constraints that I'll be talking in later slides, but this is the general idea. View models needs to be JSON serializable so there cannot be, for example, many stuff from the system.io namespace. As you can see in the example below, if I tried to write, for example, a property of type file info into a view model, our Roslyn analyzer with rule .vvm02 would immediately issue a warning notifying you that this is not something which is supported. And this is really helpful if you think about it, because we are trying to shorten the feedback loop. So as you are writing your .vvm view models, you get these warnings immediately and not during runtime, where you discover at much later time that you actually wrote your application incorrectly and it doesn't really work. So this is something that we enhanced in .vvm 4.0, and we believe that these features are really powerful and will help you to identify issues in your .vvm code base much easier. And second example that I would like to show you in connection with Roslyn analyzers is that we are not only trying to identify straight-on issues, we are also trying to avoid users from writing code which could be okay, but is probably problematic. So for example, if somebody was to write a public field inside a view model, for example, public modifiable field, then we know that this is probably something not right, because as we all know, in DotVVM you always store your view model state using properties. And don't get me wrong, it's perfectly legal to write fields inside your DotVVM view models. For example, you can use private read-only fields if you need, for example, to inject a dependency or some static fields, so for example a constant or something. But writing a public field, that suggests that the user maybe wanted it to get serialized, and that is something not supported. So as you can see in the example below, we also issue a warning for this. So in this example, user tried to write a public int field and it got caught up using our Roslyn Analyzer. So yeah, just to conclude, in terms of code analysis, we have now two pretty powerful tools. The first being, of course, Visual Studio extension for .vvm, pretty powerful tool that has been around for many .vvm versions. And right now, since .vvm 4.0, there is a new tool, basically Roslyn Analyzers for .vvm. So feel free to use them. Watch out for any warnings, as they might also discover some potential issues in your code base. Okay, so this was regarding to code analysis, and right now I would like to approach the second topic of this presentation, and that will be JavaScript translations. JavaScript translations, what are they? What does this concept bring to .vvm, and what are they used for? So to put into simple words, JavaScript translations are small pieces of code that basically provide a JavaScript equivalent to certain .NET methods. And what do I mean by that should be pretty clear from the next couple of slides. So as you all know, .vvm makes it able for you to call certain .NET methods inside your value bindings or your static commands. So in order, however, for this to work, .vvm needs to know their JavaScript equivalence. And I'll describe in a few seconds what do I mean by this equivalence. But you need to understand that since this is not something like Blazor, where we would have a WebAssembly version of the common language runtime running in client's browser, we are relying on JavaScript, so we need to provide a JavaScript equivalent of certain .NET methods. And what do I need by the JavaScript equivalent is that we want to implement similar methods whose observable behavior and their result for the programmer is same as if they were executed by the common language runtime, basically. So JavaScript translations basically define translations from .NET methods to JavaScript, and that's basically the general idea. And why is it good and useful in .vvm? Basically, it allows you to use various .NET methods inside your bindings, because value bindings and static commands can be directly executed, are directly executed in clients' browsers, so there is no communication with the server whatsoever. They are really performant and really good when it comes to the network traffic, because they generate literally none of that. So yeah, this is what JavaScript translations are. And if you are asking, well, what .NET methods are supported, because I told you that not every method is supported, because in order for you to be able to call a .NET method inside your value bindings or static commands, there needs to be registered a JavaScript translation. So if you are wondering what methods can you actually use, feel free to check out our documentation. There is an exhaustive list of many methods that is growing almost every .VVM versions, because lately we've been adding so many. And if you are wondering where to find it, just go to our documentation site, and under concepts, under section data binding, you'll find a site called supported expressions, where you can find all the syntactic expressions that is supporting by our data binding system, along with an exhaustive list of all the supported .NET methods. But I'll speak about these also on further slides. So now the question is, how can I write my own JavaScript translations? Because it may be quite common that you have a pretty handy function, method inside your code base that you would be happy to be able to call from value bindings or static commands. But in order for that to be to compile successfully, you need to first define the JavaScript translator for that. And how can you do that? So the first step is to basically create a generic, to instantiate a generic method compiler. And bear with me, on the next slide I will show you what it actually means, because on this slide it may sound way more complicated than it actually is. And once you have this translator ready, you just need to register it in your .vvm configuration, and after that you are able to use your new .NET methods inside value bindings and static commands. So to give you a concrete example on how this actually looks like, so let's assume for a short period of time that .vvm developers forgot to write a JavaScript translator for the length property on arrays, as we will be implementing it by ourselves right now. So what do we need to do in order to support this? So as you may know, properties in .NET are basically syntax sugar for a backing field and a getter method and a setter method. And when it comes to the length property, the setter is of course not accessible, but we will be using the getter method in order to query how long is the array that we are working with. So we will be providing a JavaScript translation for the getter method of the length property on arrays. So whenever you are basically defining a JavaScript translation, you always need to tell .vvm how to transform individual arguments of that method in order to produce the correct result or the correct action as .NET runtime would. So in this case, we are accessing the 0th element of arguments, which is the secret this pointer or the current instance that we are calling the length property on. And since you may know that .NET arrays are translated to JavaScript arrays when they come to client sides in .vvm, it shouldn't be surprising as arrays are mapping to another arrays, but I'll be talking about which collection translate to what types on client side at some slides a bit later on. But right now, you just have to believe me that .NET arrays are mapping to JavaScript arrays. And since we know this, in JavaScript there is a field called length. Similarly as in .NET, it's just with the lowercase l, not a capital L. And in order for us to finish this translation, we just need to tell that on this first, the 0th argument, we will be accessing its length field. and that's basically it. That's how also the implementation works in .NET. So this is a really simple translation, and the second step that you need to do is to register the translation. And to register translation, you basically need to add it to a correct collection inside your .vvm configuration. And in order for you to do that, inside your configuration, you need to go to the marker property, to the JavaScript translator, and under that, inside method collection, call one of our utility methods. There are many of them, and there is even a utility method for registering translations for property getters. As in this case, we will be adding a property getter translation for type array, and we also need to provide the name of the method that we are registering the translation for. So for that, we can use the name of operator, so that the translation is registered to the length getter, and then we just provide the translation that we created in the step above. And that's basically it. After this, which isn't that hard, you have your own new JavaScript translation. So I think the steps are pretty straightforward. But of course, if you need more information on how to create your own JavaScript translators, feel free to go to our documentation page, where under concepts, inside control development, you will find a page called custom JavaScript translators, where you will get much more information about how all of this process works, how is it implemented internally, what does these arguments that I was translating, what do they actually represent, and along there are also some further examples that you can examine, and that should help you to write your own JavaScript translations. But of course, if you find yourselves in troubles with defining your own translations, don't forget to write us on either GitHub or Gitter. We may guide you with this process, or even if we deem that this feature or this translation could be beneficial also to other users, we might just implement it ourselves and basically add it to the framework, so that every user can basically access the translation in the upcoming versions as well. So yeah, this is the process of adding new JavaScript translations. And if you are asking yourselves what can I provide JavaScript translations for, the answer is pretty straightforward. Almost to anything. We basically support instance methods, we support also static methods, and we support extension methods. DotVVM even supports some advanced constructs, such as variable arguments length, using the params keyword that you may know from C#. And if you want to know where are the limitations, where it mostly all boils down to the fact that we cannot basically support by reference arguments, so C# keywords such as ref, out, or in. Methods with these types of arguments are not and will not be supported. But other than that, I think pretty much every method that you can think about should be able to provide a JavaScript translation for. So if you find a .NET method that would be beneficial for you from your own code base to be callable from value bindings or static commands, you can now just write a JavaScript translation for that, have it registered by the .vvm configuration, and our compiler will automatically pick it up and it will just work for you. So this is it for the JavaScript translations. And right now I would like to approach the last topic of this presentation. And in this topic, I'll be speaking about supported types in view models and collections and operations that you can use on these types and stuff like that. What's changed in the recent few versions of .vvm. So yeah, let's get straight into it. So what can you actually write into view models and have it serialized correctly? So you can work pretty much with almost every numeric types, so ints, longs, and decimals, and whatever you can think about. Also chars, and from the non-primitive types, there is support for the basic stuff such as strings, GUIDs, enums, datetimes, and of course for all value types, we are also supporting their nullable versions. When it comes to collections, we support arrays, lists, and even dictionaries that you can use inside your view models. And if you want to create your own custom types, the rule for that is basically very simple. Whenever your custom type consists only on previously supported types, your type is also automatically supported. And there is one little addition that we are introducing in .vvm 4.1, which is now already in preview, and that is that we are supporting also records and structs. Not only classes anymore, so since .vvm 4.1, you'll be able to use also records and structs. And since we also added a rich type metadata that's being sent to client side, we now basically made view models really safe. So since .vvm 3.0, there is a coercer that is checking that you are assigning always only supported values into every property. And this also introduced a bunch of other cool features such as immutable states and many performance features as well. So yeah, when it comes to supported types in view models, in .vvm, I think it was 3.1, we added support for dictionaries, and in .vvm 4.1, we are extending the support of custom types with records and structs. So since .vvm 4.1, I mean, you will be able to use these as well. But right now I would like to talk a bit more about collections, as these non-scalar types are quite common, and I would like to speak a little more about them and what you can actually do with them inside .vvm. So first of all, of course, arrays, simplest data structure there is probably. When you are working with arrays in .vvm, you can of course use indexer using those square brackets to access an element, to read an element, of course also to write an element, and when it comes to properties, we are supporting the length property, which from previous slides you should be able to now also implement yourselves, as we learned on previous slides. So when it comes to arrays, indexer and length property. And arrays, shouldn't be a big surprise, are represented as JavaScript arrays when serialized from .NET and brought over to client side. So yeah, arrays pretty simple. Let's get into something more interesting. So lists. Lists are basically resizable arrays, and we support way more operations there. So it shouldn't be a big surprise. There is also this indexer that you can use both for read and write operations on individual elements. And we also support basically define many JavaScript translations, so we can support also various methods. So we support methods such as add and add range, so you can add one or multiple elements using one simple method call. You can clear all the elements from your list, and you can also insert a single element at a specific index or a range of elements at a specific index. You can remove an element at a specific index, or you can remove even all elements that are matching a specific predicate. And of course, methods such as remove range, reverse the list, and even some extensions of our own that we introduced, such as add or update, remove first and remove last, all of which take lambda expressions as parameters, so you can describe some more complex operations on lists. And when it comes to properties, we support the count property, which is really similar to the length property on arrays. And yeah, I mean, lists are also represented as JavaScript arrays when brought over to client side in JavaScript. So yeah, but it shouldn't be that big of a surprise. And we also support one more complex data structure, and that is a new addition, I think introduced in DotVVM 3.1 or 3.2. Dictionaries in .NET, as we all know, is a collection of keys and values. And when it comes to operations, we support, of course, again, indexer, both for read and write operations. And when it comes to methods, we support the clear method, the contents key query, and we support the remove method. If you are wondering why we do not support the add method, we didn't want to actually include this method because in .NET it has this behavior that if you are adding an element whose key is already in the dictionary, you would get an exception. Whereas if you are using the indexer for this set operation, it would just replace the key. And the behavior of throwing exceptions would be harder to replicate JavaScript. And we also didn't want to throw exceptions needlessly. So we are encouraging users to use the setter capability of the indexer. But of course, if you feel like you would make use of the add method, you can just add the translation yourselves. And when it comes to the JavaScript representation of dictionaries, we are also using arrays, and the dictionary is stored as a collection of key value pairs, which are of course stored in no particular order. So that's the way that dictionaries are represented in JavaScript, if you were wondering how we are achieving this. So yeah, I mean, this is so much for collections. So what changed in the past few versions? Mainly that we added type metadata, we added support for dictionaries, we added a bunch of JavaScript translations, so you can perform various operations inside your static commands on these collections, which is pretty cool because you can do sometimes quite complex operations just on the client side with no communication with the server whatsoever, so it's really fast. And yeah, we also added support for dictionaries and support for structs and records, which will be released in the version DotVVM 4.1. And if you cannot wait, you can actually try it right now, because there is already a public preview that should have this capability already for you to try it out. So yeah, and of course I wouldn't forget about the many other methods that you can actually call on these collections, because we also provided in the past couple of versions a lot of JavaScript translations for many link methods. So you can use various link methods to basically perform, for example, client-side filtering of many sorts. So, for example, here I have an example. So let's just suppose that you, for example, have a repeater where you want to render on some special case, on some special page, only customer with first name Ben. So for example, it might be the names day and you would like to send a happy names day to them. So you can filter them easily as this. You would just call the where linked method on the customer collection that you have in your view model, and then just perform the filtering using a simple lambda function. And as I told you before, you can check out our documentation where there is a really long list of all the methods that we are supporting, and in recent versions we added a bunch of more, for example when it comes to string method translations, or even some translations on date times and so on and so forth. So yeah, these are the main operations that you can use, for example, when working with your types inside your view models. And yeah, I mean, just to conclude this presentation, use our tooling, both our Visual Studio extension and the Roslyn Analyzers. They are both pretty powerful tools. They can help you with writing your .vvm code. Not only that they provide these nice functionalities such as IntelliSense, code completion, and stuff like that, but it can also be helpful when discovering some issues inside your code, so you can react to it much faster, rather than later finding out during runtime that something crashed or couldn't be compiled and stuff like that. So yeah, in .vvm 4.0 we introduced Roslyn Analyzers that would guide you when writing your for example view models, and making sure that you won't use something unsupported. So you can also, as we learned in this presentation, extend our binding system with your custom JavaScript translation, so you can use some new shiny .NET methods inside your value bindings or static commands, which is a pretty nice feature and a quite nice way on how to improve the binding system and learn it to work with new .NET methods. And of course, in recent versions, we introduced into view models rich type metadata. We added support for dictionaries, and also when it comes to custom user-made types, since .vvm 4.1 we will be also supporting structs and records, so not anymore only classes. Also these other tools will be available for you when writing your .vvm applications. So at this point from this presentation it will be all from me, but stay tuned for our next presentation. In the next presentation I'll be talking about many validation improvements and our roadmap for the next versions. And so after a short break we will be back live, and until then, thank you for your attention. So, hello everyone and welcome back. You are watching the DotVVM Virtual Conference, the second day, and this is also the second presentation for today. And even after this, there will be two more, so there is still a lot to be looking forward to. And my name is Andrei. I'm one of the developers for the DotVVM project, and in this presentation, I'll be talking to you about validation improvements and our plans for the upcoming versions regarding the validation. So, validation. In DotVVM 4.0, we actually did a bunch of work on validation. Actually, I would say we basically rewrote the whole thing and the way it internally works. I mean, it's not that observable from the API that users use, but the way it works internally is now basically completely different. So let's take a look at it. But first, let me just briefly recap on how validation worked in versions 3.x, so that we can better appreciate what's new in this validation subsystem. So, validation in DotVVM 3.x, when it comes to creating validation errors, there were basically three options. The first, the most common and the most encouraged options is of course to use our automatic validation mechanism. So how does this work? So I'm pretty sure that most .vvm developers are familiar with it. So you can use it, for example, by writing a required attribute on some of your properties. And during validation, for example, on postback, we will check that this constraint of your holds, so that the property was actually set and has some meaningful value. So this is one way on how validation errors can be generated. So for example, if you have this required property and it wasn't set, you would get a validation error. So what's the other alternatives? So you can, of course, also create validation errors manually. And you can either do it using a compile time safe API by providing a lambda function that points to a property that is in violation where those validation errors should be attached to. And this is also perfectly fine to do, because based on some backend logic that you have on your running on your server, you may discover that something is not right and you need to attach some errors manually. And the third option that was available for users, which was not really common and for good reasons, is to write property paths manually. And this was really cumbersome in the previous versions because it required users to write knockout expressions, which means that we were leaking a little our internal implementation on how this validation system works. And they were also pretty hard to write sometimes, as I'll be showing you on the next slide, where I'll be comparing it to the new approach. And also, so these are the three options that were available for you when creating validation errors. Mostly there, I mean two, but the second we can distinguish whether you use compile time safe API or you were using these unsafe knockout handwritten expressions. And what was the next important thing about validation was validation scopes, and the way you determined the scope of validation is by setting validation targets. So if you, for example, you have a very big view model and on your page you are working with its small subsets. So for example, a user is currently filling out a form. So you would naturally set the validation target only for that smaller part of ViewModel, because that's the part that you want to actually validate only. And in the recent versions, you were not able to create any errors outside of this validation scope. It just wasn't possible. So now that I shortly recapped how validation worked, let's have a look on how we improved it. So the first big and important improvement is that we are no longer using these old and not really nice knockout expressions when expressing property paths. If you are wondering and never saw this, how did they actually look like, you can see them in this short code example that I prepared. This old format of property paths is expressed with this red color. You may notice there are so many parentheses. That's because we need to, since we are using knockout, we need to unwrap individual observables until we get to the target property that we want to assign a validation error to. So this is not really nice to write nor to read. So we basically, the new property path format that we are using right now, you can see in the lower part of the code sample. I think we can all agree that it's much nicer, human readable, and it has some other important features as well. It is unambiguous because those paths are always expressed from the root view model, so there is no ambiguity whether this is just a relative path and what is the context that we should evaluate this path on, and so on. So we basically redid how this works. You actually don't need to, of course, write these paths, but it's really helpful to at least have some sense on how they actually look like and what do they mean, because as I'll be showing you on later slides, we are right now showing these property paths whenever displaying validation errors to users, because they are now pretty nice, easily readable, and can help you to identify the root cause of validation issues much faster. So if I was to look at this example that I prepared here, what does this this lower property path actually means? So you may immediately notice that it starts with a slash. This means that this path is rooted, and this means that it's basically starting from the root view model. And in that context, it also means that in the root view model, there needs to be a property called users collection. So yeah, probably a list or an array. And we found out that we want to attach an error to its first element. So that's why there is this 0, because there is an issue with the first user inside of the collection. And in that object, there must be a property called post, and it must have a child property called post text, and this is something that we are attaching the error to. So it's basically just a way to describe the path from root view model to the target violating property. So that's what these new property paths actually mean. So, okay, this is pretty nice. What else changed? So, validation targets overriding. So, as I previously mentioned, In DotVVM 3.x, you were not able to override validation targets. Well, now you can. You can manually add a validation error, but of course, this does not apply to the automatic validation. So this doesn't break anything. The automatic validation is always respecting the validation target. But for example, if you decide that regardless of the fact that you have set a validation target and would really need to set also validation error, for example, to the root view model, you can do so since DotVVM 4.0 because this is also supported. So new property paths and overriding validation target when manually adding validation errors. So what is the next change that we did? So we also improved API for creating and adding errors to model state. So you can now specify validation errors based on more complex requirements. There are new overloads that you can take advantage of. And yeah, if you are wondering how it actually looks like, I prepared a small code sample. So there are many overloads on validation error factory. So for example, here is one, add model error that takes a view model reference. So for example, I am passing here a reference to a form view model that can be nested somewhere on some path that is reachable from our root view model. And then from this form view model, I want to attach the new error to its ID property. So we are basically saying that there is something wrong with the ID, and then of course the descriptive error message. So as you can see, you can basically provide two parameters. You can set an object that should be automatically found by DotVVM. So internally, DotVVM will basically resolve the path from the root view model to the form view model. And if this is reachable, if the object is reachable, then we know that the validation error should be attached to that object. And then we will just concatenate it with this path that you provided using the lambda function, and we get the whole absolute property path from root view model to the validation, to the violating property. So this is just a single example, but there are many other overloads, simpler ones and also a bit more complex ones, so that you can express many errors with ease. And basically we think that we covered all possible use cases with this new API that we introduced. So yeah, and the important thing that I briefly mentioned but haven't talked much about, whenever you are manually adding these errors, we will perform a reachability analysis. So for example, what it means that in this case, the form view model needs to be reachable from the root view model. And if it's reachable, the error will be added to the model state. If it's not reachable, we will determine that, okay, there is an error, but the error is not referenced from the view model, so we are not showing it to user because it's just not there. So even if you make a mistake by referencing something that is not reachable, it won't be a trouble. We just wouldn't find the path and would discard the error. So yeah, validation improvements when it comes to the new API and reachability analysis. This is also another important improvement when it comes to validation. And as I've been saying about those property paths, we are now displaying them also to users. So for example, if there are some validation errors sent to the client, or basically displayed in the JavaScript console for any reason, you would now get not only the error message, but as you can see, there is also this property path, which basically in this case is telling us that at root view model there needs to be a property called detail, and this property has a child property called name, and that's basically the violating property. So we believe that this addition can be helpful when analyzing what is the root cause of your validation problems. So whenever, for example, in this case, a postbag is cancelled due to some validation errors, you would also get these property paths so that you can basically just straight go and inspect the view model at that specific place to know what went wrong. Because these error messages on their own are not that great at describing what is the actual place inside a view model that has been violated. So I think that this is also a great addition. And lastly, I would like to talk about one more addition that is not yet available, but will be available in DotVVM 4.1, and that is that we are adding a JavaScript API for modifying errors. Now, I am not really expecting that many users will be using this API, but it is nice that it is there, because it is also laying the groundwork for us for our future work that I'll be talking a bit later about, that we want to perform a validation also during static commands. So just a brief overview so you know what we are working on internally. Just a few days ago, we basically added 2 new functions. One that can be used to add new errors inside when working on client side, and also another method called remove errors that can be used to basically detach all errors on given property or given properties. So yeah, this is also a pretty exciting change, although apart from those previous ones, I'm not really expecting many users to use this one, but it's also important that it is there. So these were the validation improvements that we did. I mean, the most important changes that we did for validation in DotVVM 4.0. And now let's take a look at what does this mean for you when you are upgrading your older applications, for example, from DotVVM 3.x, and what breaking changes are there basically. So as I've been saying, there is this new property path format, but unless you actually use the API where you would manually write those knockout expressions, you wouldn't be affected by this change at all. It's just an improvement, so whenever you now see validation errors, they will get these nicely readable property paths. So model state is now immutable. That is the next breaking change. In order to create new errors and have them attached to the added to the model state, you need to use our API. There is no way around that. We needed to keep the model state consistent so that we can make some further changes. But yeah, I mean, those factory methods have been around for quite some while, so unless you've been manually changing model state, which I don't believe is quite often, you wouldn't be affected by this either. The next breaking change is that viewModel validation error, our class for holding validation errors, is immutable as well. But yeah, I don't really believe that that many users were actually changing those errors once they were made by our factory methods. So this shouldn't be an issue for many users as well. And lastly, we introduced a new method called addRawModelError, which can be used if you want to add new validation errors based on a handwritten property path. And this method is only accepting the new format, the new nice readable format, not that old, quite cumbersome knockout expressions. So yeah, if you were using manually handwritten paths, you just need to use this different overload. But yeah, I mean, that's basically all. So if you were basically relying on automatic validation, and you have been using our API for adding manual errors, I mean those various factory methods, you shouldn't have any troubles updating whatsoever. But it's still helpful to keep these changes in mind in case something happens during your upgrade process. So yeah, I mean that's basically it for validation improvements and the validation breaking changes. And right now I would like to briefly outline what is coming next when it comes to validation in future versions. So some of it might come in 4.x or even 5, I mean the next major version. So there is not really a strict time when this will be available, but we have already a pretty clear idea on how to implement these new features. So let's take a look at what you can expect in the upcoming .vvm versions. So the most important thing when it comes to validation that we want to improve, I mean implement as a new feature, is validation for static commands. So validation for static commands is something that hasn't been available in .vvm, and regular validation has been around since its very early versions. And in order for us to implement validation for static commands, it has to work in a bit different way. So when we introduce validation for static commands, the biggest difference will be that it won't just validate viewModel, it will be validating the arguments that are passed to the static command invocation. So if you think about it, those things that you were able to specify for validation, so for example validation enabled or validation target, these won't be applicable to validation in static commands. These will, however, still stay there functioning for regular validation, for example, whenever you are doing postback, because you can still disable validation for some parts or basically delimit the scope of validation by setting a validation target. But this is something a bit different as to what we will be doing with the static command validation, because we will be validating only arguments. So what does this mean? So for example, we will be adding new factory methods for validation errors, such as in this example, add command argument error, where we will describing which argument is being violated, and then, for example, an error. Of course, there will be more overloads. For example, if you want to attach the error actually to some child property of the argument, there will be a lambda expression. There will be even probably a way for you to describe handwritten paths if you feel like you need that. And yeah, I mean, it will be really similar, but you will be attaching these errors not really to viewModel, but you will be attaching them to individual arguments. And you may be asking yourselves, okay, this is interesting, but we are still attaching these errors only to arguments. I mean, how will this reflect to my viewModel? Because we now have a already existing systems, I mean, already established mechanism for attaching validation errors to individual properties inside your viewModel, so you can do some further operation whenever there is an error attached. So of course we will try to reflect these validation errors based on the paths or the expressions that you provided to us, to map them or match them against the viewModel. So we can of course do this for most cases, because in our experience, whenever we are doing I mean command invocations or static commands invocations and passing arguments, people usually tend to put individual properties as arguments, which is quite common. But you can also write there some more complex expressions. And what we are basically trying to say is that when you provide us with this validation error for your argument, we will basically recalculate this path and try to match it to that absolute path inside your viewModel, so that the error will be attached in the same way as you are used to right now. I mean, of course, there are some limitations. So for example, if you take a look at this code snippet that I wrote here, you may see that there is a more complex expression. So for example, we may write a static command that would take a string name property, and we may write there this conditional ternary operator that would, based on some logic, decide whether to pass their property A or property B. But this is quite problematic, because when we find out that this argument is in violation with your defined contracts, we would not be really able to easily match this to a property, because we are not really sure which property was actually used for the invocation. And I mean, we will try to do our best to implement this in such a way that common expressions will be matched. Those properties used in those expressions will be matched to your viewModel, but it will be probably the case that with many complex expressions, it wouldn't be really feasible to try and match them, and some cases might be even too hard to even try that. So, but for the most part, what I'm trying to say, we will be matching these validation errors against the viewModel as people are used to. So there will be just new API. You will be assigning individual errors to arguments instead of directly viewModel, and we will take care of the rest. We just have to come up with a best way on how to basically enable the validation for static commands, because since it hasn't been around since earlier versions of the DotVVM, just turning on static command validation by default could be considered a breaking change for many users. So there will probably be a global setting of some sort where you will be able to turn the validation for static command on or off. But yeah, that is yet to be determined. But I'm guessing that for new project, it should be turned on by default, as once this comes out, it will be a really nice feature, because then we would have a really nice working system, validation system, both for commands and also for static commands. yeah, so that's the brief overview that I wanted to show you. And just to conclude this presentation, since DotVVM 4.0, we did a bunch of work on validation, basically rewrote the whole thing, and now it works, in my opinion, a lot better. Property paths are human readable and ambiguous. They do not leak our internal implementation, and I mean are nice to look at and easier to write. So yeah, I mean that's really nice to have, of course. And we are now supporting, since .vvm 4.0, some more advanced scenarios. For example, you can manually attach errors outside of your defined validation scope by set validation targets. So you can basically override this behavior. If it, of course, doesn't affect the automatic validation, but whenever you are manually adding errors, you are now able to override this behavior, if you choose to do so, of course. And improvements on client side is another important stuff that we did. We are displaying more descriptive errors in JavaScript console, and we are also introducing a JavaScript API for working with errors that will be coming in the upcoming versions. So, and of course, as I described on the 2 previous slides, we basically finalized our technical roadmap for validation in static commands. We have a pretty clear picture on how to implement this thing, and so you can be looking forward to it in the upcoming versions of .vvm. So at this point, I would like to thank you for your attention. This will be all from me for this presentation. However, after this, there will be also 2 additional presentations with great speakers. So yeah, there is a lot to be looking forward to. So until then, stay tuned, and thank you for listening, and have a nice day.
Hi, I'm Standa. I'm one of the DotVVM developers, and in the third presentation today, I would like to show you what we are essentially still working on, but it's released in DotVVM 4.0 in like the experimental stage. I would like to show you our integration with JavaScript components. The idea is that you might want to use some existing like React components or whichever framework you like in the .vvm application, and there is a ton of free and actually quite well-written React components on the internet or in like the npm repository, and also many commercial components have React bindings. The commercial components usually started as like jQuery or jQuery style APIs, but nowadays basically everything has React bindings and probably some other frameworks. Now we basically mostly focus on React because it's the most used one, but we want to add support for multiple frameworks later. So in this presentation, I would like to show you basically what we came up with, what works, and how you can use it. And I would also like to show you like what we plan to do and kind of how it works on the high level. So as I said, the main motivation is to use existing components, but like a secondary and not that unimportant motivation is to be able to use, to be able to write some complex client-side code, because some tasks are really tedious in like pure .vvm, or you would have to write also some custom JavaScript, which is then hard to integrate with the Knockout observables that we use. And I don't want to say that Knockout is like a bad framework. It's certainly like fallen out of fashion these days, but it's not bad for templating. I would say it's quite tedious to use when you want to write components. So we basically already have multiple APIs for integrating client-side code with .vvm. Like from the first versions of .vvm when it was called Redwood back in the day, if some of you remember. It was based on Knockout and Knockout.js, where you can write custom binding handlers, and these can be used seamlessly from .vvm. You essentially don't even need to integrate it with .vvm, since you can just include the data bind attribute in your .html code, bind it to some view model property, and it will just work. And most of our components are actually written this way. Basically all of business spec components, if you have used them, and also most .vvm bootstrap components have some custom binding handlers. However, for writing custom code, which is more involved than just calling some function from the bootstrap library, it's sometimes a bit annoying because Knockout does not offer much abstraction above the DOM API. And you also have to handle a lot of Knockout specific edge cases, so it's maybe even worse than like writing it in jQuery. So quite some time ago, I think it's at least 3 years, maybe even more, I wrote like a proof of concept, a React bridge, which still is in .vvm contrib. I am afraid it kind of stopped working and nobody complained, so probably nobody ever used it. But it was like a proof of concept that it was possible to actually integrate React components with .vvm even some time ago. And we used it for some demos and not for much else. There are some major problems with the React bridge, mostly that it was really annoying to use with JavaScript modules and with bundlers such as Webpack, which is kind of required to use if you want to use any third-party React component or class. So in this way it wasn't super useful. because the limitations were clashing with the real-life requirements. Last year, Tomáš, mostly Tomáš, was writing Fluent UI integration using web components. Web components have the advantage over like React components that we essentially don't have to do any work to make it work, because web component is exported as like a virtual HTML element. So there is like no way DotVVM wouldn't support this, because DotVVM just renders HTML. So yeah, you can use web components, but there are also some limitations, like binding two ways is like, it's not impossible, but it's not like as trivial as it would seem, because Knockout can write the values into attributes, but it cannot read them back from attributes, because normal HTML elements just don't change their attributes on their own. So we had to write some custom Knockout handlers to make this work with the Fluent UI. And it's quite annoying also to send any more complex object than like a number or a string through the HTML attributes, because HTML attributes are only strings. So now we are working on another integration. We call it JS Components. It should essentially not have all the limitations that I just told you. So it will be based on JavaScript modules, compatible with bundlers. We use Rollup mostly, because it's like simple and works. And we also want to make it work with React components and maybe something else. So, as I said, it's based on ECMAScript modules or JavaScript modules if you have used them. It's based on our add.js directive. I don't know how popular it is. A lot of people in our company use it, but I don't know about everyone else. But it's a way to include an JavaScript module into a .vvm page and then integrate it with the page. So you can call functions on the module from .vvm bindings, from commands, or even from value bindings. And with this support, you can now also export components from that module that you just loaded in the page into .vvm. And currently, we have like a first-class support for React, and we also support Svelte, because I like the framework, so I just wrote the integration. I will show you later. It's really not hard. It's like 10 lines of code to get basic React support, and basically the same for Svelte. So if you are using some obscure JavaScript framework, just get in touch, and I will happily help you to integrate it as well. It supports bindings. They work two ways in Svelte, only one way in React, because React just doesn't have two-way bindings. But what you do in React, I will show in a moment. You just add a command into there, or static command, which is basically an event handler for the like unchanged event. So if you, I don't know, have a text box and you bind into it the value, and then you bind it out of it using a like unchanged event. And it also supports templates that can be placed into the components. That's a bit more involved. I will not show it today, but we support it. And we are still working on it, so please keep in mind that there might be some rough edges. I don't want to discourage you from using this API. Just expect that if you do something non-trivial with it, there might be rough edges. But if you encounter those, please get in touch. We will happily help you. And second, most importantly for us, we will get some feedback on it and maybe fix the problem actually. So let me show you a demo. I found a nice React component on the internet. It's called React dgraph. Dgraph means like directed graph. It basically shows, here you can see an animated demo. It renders an SVG elements which show like a combinatory graph or a diagram. So you have nodes and edges, and it will just render those. It has quite complex API. So it's the usage won't be as simple. Here you can see like a simplified example usage. The usage won't be as simple as like now just export this function to the VVM. Maybe it would be possible, I don't know, but it's probably even like more educational to show that the better way is to write your own component that will wrap the functionality from this one which you need to use, and then export your own component to the DotVVM so that you can avoid some rough edges of the API by binding simpler objects and simplifying the events and so on. And we will also do like a backwards data binding, because the component allows changing the position of these events. It also allows adding new edges, but I was too lazy to implement support for that. So we will only support binding the positions back into the view model, and I will show you that you can then modify it either in the DotVVM page or then in the React component. It doesn't matter, it will be bound together. So let's start. I have prepared a demo. I don't want to embarrass myself even more, so I don't want to do any live coding today. So it's already implemented. I will just show you how it's done, and then we will have a look how it works. So first, there is like the boring part where we have to set up all the JavaScript build systems things. We can't simply import the JavaScript module into the page because React essentially doesn't work this way. We even had to do some like slight hacks in the rollup config. React has these references to process.env, .node.env, so it will not even work in the browser if you just load it. You have to essentially compile the JavaScript using a bundler like Webpack, or here we use rollup because it works nicely with ECMAScript modules. However, the setup is fairly simple. This is basically the boilerplate that you always need for rollup. This is like, okay, we want to use TypeScript. This is a hack for React that everybody uses. And then there is like an optional minification step. So nothing super complicated. If you didn't see this, maybe you are just scratching your head, what the hell is this? But it's essentially like from any template you would copy paste it. I also pre-installed some packages. It's mostly the rollup plugins and this React dgraph package. And I didn't use it here, but that's not super important. I also imported this .vvm JS component React package. That's like the important entry point to the React integration API. It's an npm package. We cannot distribute it together with the NuGet .vvm package, or maybe we could, but it would be like complicated, and you need npm anyway for importing React. So this is a simpler way to do it. So we just import React. We import the .vvm integration, which is only this function, register React component, and we import the necessary stuff from the React digraph library. I will not go into details how this library is used. That's kind of off topic. You can just quickly glance through the code. I will show some slide details later. And then the like important part from .vvm point of view is that you export like initializer function which returns an object which has these dollar controls. It's called dollar controls because anything which is not dollar prefixed is like a command that you can invoke from the .vvm JavaScript. So .vvm will expect that if you write something in here like test and I don't know, we will not call it so we don't get the alert, but this will be like an invocable JavaScript command from .vvm page. You can learn more about it in like our documentation. If you don't know it and want to do something more involved with .vvm, definitely have a look at this. I think it's super powerful. Okay, now back to the components. So we call this register React component, which is essentially a function which gets the component and wraps it into like a .vvm compatible API. We have designed some like framework agnostic API for .vvm so that we don't have to import React into .vvm, which would increase the bundle size like 3 times. So we didn't want to include React in .vvm, so we added some like React-ish API, and it also allows us seamlessly to integrate Svelte or any other framework that we will later want to utilize. So the React component, if you didn't see in React, React component can be just a function which gets like its properties and returns an HTML element. This is like a special JSX syntax. It's not valid JavaScript, but it's also one of the reasons why we need the pre-compilation step. So these properties we get from .vvm. It's used here in the .html page. Maybe I will increase the font size slightly. And here we use js.diagram, which is a reference to this name. So we register the component as diagram. Here we use it as diagram. And all the attributes that we add here will be passed here in the props object. So we just use JavaScript deconstructions to get all of them. We are rendering like a graph, so we need nodes and edges. And here are 2 events, like one for the node position is changed and one for selection changed, because we can also select nodes in this library. We just transform whatever we have in the view model. I will show you what we have in the model. It's just very simple view model with there are nodes, each has a position. We have a list of nodes in the model, and then we have a list of edges. And edge is just a from and to name of the node. I was too lazy to add some numeric IDs. So we transform whatever we have in the .vvm view model into whatever the React component expects. And here I have another component which is stateful this time because they had it in the example this way. I didn't want to bother too much with adjusting the example, so I like it more. So this is a stateful React component, and it handles like this on update and on select, so that we can then bind it back to the .vvm view model. It's not super important whatever is here. We just take the edges that we created here and nodes that we created here and pass it into this graph view component, which is imported from the package. So, does it work? I had it running. I am not sure if it was the latest version, so I will just build it and just run .NET Run again. I think I should have it open here. Yeah. So this is the React component that we included. It has these 3 edges. The custom field is like a type of the node. That's also copy pasted from the example. You will probably want to have something your own here. And you see the names here, and that the links are just as we specified in the .vvm view model. So this essentially proves that we can bind data from .vvm into React. So does it work the other way? Here I have placed the table of the node positions. These are the default positions that you can see in the view model. The table, if you are wondering, is just implemented as a simple repeater over all nodes. And we can also edit the positions client side. Nothing spectacular, just to prove that it works. And when I drag the component, I will also show you the debug window. Because I placed some debug print so we can see whatever is going on. I can drag the component slightly, and you see nothing is changing because the GraphLink library does not trigger any events when it's being dragged. But now when I leave the mouse button, it triggers an event on update node, which has this that node 1 was updated with these positions. That's printed from here. And from here I also invoke the .vvm event node changed, which is bound here into a static command. If you don't know, static command is like a command binding that you are used to from .vvm, but it works only client side. So this does no request to the web server, because it's pointless to do a request just to update position of one node. And you can see that like we can use first or defaults to find the node that we are interested in and then just set the position. You can also pass more complex values like this position view model. Like it's not super complex view model, like to be honest, but it's not a simple string value. Here we created in JavaScript in this like object literal or however it's called. So this is how it works, and you can see that whenever I drag this node, there is an updated position. And naturally, when I change it in here, in this text box, the position of the node also changes, so I can just reset it back to 0, 0. Oops, now it's overlapping, so I can just drag this away. Okay. So this was fairly simple, and just to show you like one potential, not a trap, but pitfall potential. I also added support for this selection changed. Whenever we click on a node, or I hold Ctrl-Shift and select it, we can select some nodes from the graph. And the React component has this onSelect event where we get the selection, where we have a list of nodes. If it's empty, they use null, so I just translate it to an empty array because I think that's more natural, at least in the .vvm world. And I take all the nodes that are selected and trigger an .vvm event here, which just updates the selected array. And I show the sorry, not this one. The selected array is also in this table as a list of checkbox. So you can see that node 1 and node 2 is selected. And when I unselect them, they are unselected, and so on. So it works very nicely. And you would expect now, or maybe you wouldn't because you see the problem, but you could expect that when I click on this, it will select the node, but it does not. And the reason is very simple. We just only bind it from the React component, but there is no like, we would have to do like selection is equal to value dot selected. And then I don't want to do it now. As I said, I don't want to do live coding session. But then we would have to take it from here into the graph. And from the graph, we would have to set this selected field. And now it's slightly problematic because the selection is also persisted in the React component. So we would probably have to ditch the state and just use the property from .vvm. But like, it works as long as you don't expect it to bind it the other way. And obviously, you will also encounter similar trap if you bind it only from .vvm. Like, if you wouldn't have this node changed here. Now I can drag the component however I want, and it will not update. You can see that it always drags it back because. Now it didn't drag it back, I don't know why. Usually it drags it back because the .vvm view model still says that the component should, or this custom node 2 should be at this location. And I think that it does not sometimes go back because it only updates when something changes, and actually nothing changes here, so it's not updated. But I'm not sure, I don't want to claim I know why it doesn't work. It just doesn't work. So you have to bind it explicitly to with React. Oftentimes you will find out that you will also have to do it with Svelte, but in very simple cases, like when you are binding a simple string property or simple integer property, it will work both ways with Svelte because it kind of has some basic support for two-way binding, so you will avoid kind of writing this. And I don't want to say the code is ugly, but it may seem kind of unnecessary when it's just updating the nodes back. So that's all from me for now. I just want to encourage you to, if you have a use case where this would help you, please try it out. And if you encounter any problems or some rough edges, even when you figure out to overcome them, feel free to just report to us, hey, we tried this and it didn't work, so we had to work around it. And maybe we will find a way to like lift the limitations of it. And also, if you want to have a support for your favorite client-side framework, I know there is like a dozen of them that are actually used, and probably thousands of them that are not used that much. You can try to write the integration yourself. I can show you like a quick glance. Like this is all you need for the React integration to work. There is some code above that's to make like the knockout templates work, but I didn't even show you that today. I don't think it will be too useful. So in most cases, when you want to use the integration yourself in your application, you will probably be fine with only this piece of code. So I don't know if you like Vue, I don't know basically anything about Vue.js, but if you like Vue and you know something about it, you know how to translate this React code into Vue, I think it will be pretty easy for you to actually integrate it. Or I don't know if you like something more obscure, feel free to try. And we have some plans to, as I said here earlier, most of our components now are written using the knockout binding handlers. We will probably try to switch some of them to this new API. We have been trying to do that for the business factory view. I don't want to promise that it will happen, but oops. But we will at least try. It's not that simple as I showed you now, because there is like many knockout templates with changing data contexts, and that's not very well handled by the current state of the API. But I don't think you will need it all that often in like real applications. So that's all from me. Thank you for your attention, and feel free to contact us if you want to know anything more. Are there any questions in the chat? One question.
Is the DotVVM React diagram demo repo available?
No, because I wrote it this like afternoon, and so I still didn't make it available. But I will certainly do that. Like there is no reason to keep this private. Also, if you want a few more examples of the usage, we have some of them in our like official. Oh, not this one. In our .vvm repository, what did I do wrong? I'm not connected to internet. Okay, that's the issue. But anyway, in our .vvm repository, I can show you here in VS Code. We have the samples folder, and let me quickly. Here in the common directory, there are a few examples of the usage with React and with Svelte, because we need to test it that it still works. So these are our framework UI tests. But you can also have a look. Like these are more simple than what I showed today. There is some chart which is only a one-way binding from the view model into the React component, and here there is a template selector to prove that there are like templating support works. So if you would need to use the templating, you can also have a look here how it works. And with Svelte there is something very similar. There is this incrementer component, which is interesting in the way that it is just incrementing the property which it's using, and it is binding two-way to the DotVVM view model. But I will definitely make this repository available. So I guess that's all. Thank you for your attention, and maybe see you on another video.
Hey, hola, ahoy everyone. Hey, hola, ahoy everyone. It's a huge pleasure to be able to greet you today in the DotVVM Virtual Conference. My name is Daniel Gomez, and in this moment we will have our traditional DotVVM in action section, in this case to learn about JS directive in DotVVM. It's really nice to meet you again in this event. I'm going to introduce myself. I'm Daniel from Latin America region. I work here as a developer advocate. An additional part, I have the opportunity to participate in Microsoft as MVP in the developer technologies field, also in C# Corner as an MVP as well, and as a community builder in Amazon Web Services. I'm software engineer, and always is a huge pleasure to be able to participate in event communities because we can exchange knowledge between each other and have a nice time and learn something new. So in this .vvm in action section, we will introduce the JS directive to do some features. And in this path, we will have one demo to see how works JS directive from .vvm, and then we will review an amazing demos to actually the first to learn or see how to recognize objects in images, and in the other one to have a translator of languages by text and voice, these both in .vvm web application, and finally we can see other resources as well. So we can get started. Okay, let's talking about JS directive. JS directive was introduced in this case in .vvm 3.0. JS directive is a set of features which offers many ways to have a communications between .vvm and JavaScript, and also from JavaScript to .vvm. So we can see this amazing feature because we can call literally anything in JavaScript and use in .vvm. So how it works? Uh, we can consider some steps to follow to call JavaScript functions from .vvm. And as a first point, we need to have JavaScript models to have that operation and that functions that we can use from .vvm. Then in ASP.NET projects, we have to register that model in the .vvm startup configurations to refer to that JavaScript functionalities. Then in our views, in our .vvm views, we have to import that models declared in the .vvm startup to use the operations in the other path in the views and call JavaScript functions from .vvm. So now we can see our first demo to see how to use this amazing functionality JS directive from .vvm. So in this example, we will see something very easy. The idea is have a little web applications to add two numbers with introduced by the users, and then can calculate that. The idea is from .vvm have a text box to enter these numbers, and the functionality to add that numbers call from JavaScript functionalities. So in this moment, I'm going to share a little project that I have here in my Visual Studio 2022 of .vvm. So the first point that we can consider is, okay, the JavaScript functionality. Here, let me show you in this path, in the www root, I have this file javascript.js, and here I have a class. The most important part here is that operational functionality that will allows you to add two numbers as a parameters here, and and set that result. As an additional part, we can also send some values from JavaScript to .vvm as well. We will see this later. So the first point is this JavaScript file. Then we have to go to .vvm startup, particularly here in the configure resources, to refer to GS directive. In the GS directive, we can add a configuration here to register a new model. We can specify a name to that model. For example, we can use this name, and then we can, or we have to refer to the script model results. How? Specify the URL resource location. In this particular case, the location is in the www root for the static files, and the JavaScript file we can see here and specify or refers as you can see here. As an additional part, we can consider, for example, add dependencies to send to our JavaScript files. For example, the format or structure is as we can see here, but in this case, it's a simple operations to add two numbers. So with this register of this model, we can use this functionality in some view. For example, we can see in the example in this default.html, we can use or refer to that model here with this refer with the GS and with the name of the model. The model is as we can define here with this register. And that's it. Now we can use these JavaScript functionalities in this view. So in this view is associated with this default view model class. And here we have three attributes. Number one, number two to add this number, and then have this result. So with these three parameters, we can establish our view. So the first point here is have two text box to write this number one and this number two. And the interesting part is here. Have our button, our .vvm control, to refer to this click event and call an static command. This static command can refer to GS directive here to invoke some functionality. In this case, our operation method that is established here in our JavaScript class. And then we can send the parameters number one and number two to have that process, to have the process to add these numbers. Then we can specify some references to receive some values from JavaScript as well. That is, have the communication between JavaScript to .vvm. In this case, for example, we can specify this command to refer to result operation, and the command is receive int value to this reference. What reference? In the JavaScript functionality here, naming commands, and we can refer to this result operation here, as we can see here, and send the result of the operation. And that's it, how it works GS directive in .vvm to call some functions from .vvm and also send some values from JavaScript to .vvm. So let me execute this little example. Okay, our example is here. Add two numbers. Remember, these are two text box to enter these numbers. For example, 5 and 2. And calculate is to call to JavaScript functionality. Okay, and the result as we can see here. So this is our first example to understand how GS directive works. Okay, that's it. Now we can see .vvm in actions demos to see how to use GS directive in some scenarios that we can consider. The first one is have this .vvm action demo to have a recognition of objects in images. All of these in a one .vvm web application. So in this case, the scenario is work with computer vision environment, that is to recognize objects in images. As we can see here is some interesting topic. And we will see how to use these environments in our web applications with .vvm. So the example that we can see today is have a web application with .vvm to recognize some objects. For example, in one image, recognize, for example, if there are bottles or faces or guitars, for example, and other elements that we can see in images. To do that, we have this solution implemented. As a first point, we have a custom vision resource in Microsoft Azure that help you to recognize that objects have a machine learning model to do that process. So in our part, we can consider a .NET solution as a first point, a class library to use or call that custom vision functionalities and then use in our web application. So in this case, we will focus in our web application because the idea is with yes directive have a camera JavaScript to, for example, take picture or search some pictures and analyze that image to recognize some objects and show the results in our web application. So we can go to our solution to see this process. Okay, our example is here. And the idea of this demo is in this part, take a picture or search one image to then recognize the object in it. So I'm going to search one image here. Let me search one. Okay, I use here a upload file .vvm control here. And now I can use the yes directive to load this image here and then analyze it. So let me click here, and the idea is have the objects detected here. So, okay, in this case, we have the face, the guitar, and the hat. Let me show the results here. Okay, the idea is some comprehensible in this part. We have in this part the guitar, the hat, and also the face in this image. In this little example, you know. So the idea of this example is here. And now we can go into to see the implementation of this communication between .vvm and JavaScript. So let me show you. Okay, in this part, we, as a first point, we have the JS file, the JavaScript file. Let me show you here. In this case, I have this site JS file because the most important part here is this function. Take a snapshot, in this case, to take a picture in our web application. And also we can consider this other functionality, update a snapshot, that is to update one file as an example here. And all of that, of all of these images as a take a snapshot or update a snapshot, we can save here in this path, camera photos in the www root for static files in this part, as you can see here. Probably as a future implementations, we can consider, for example, a storage accounts, for example, in Azure to save these images. But in this example, we can see the files in this folder. So the idea is that have this JavaScript file to take a snapshot or upload files, in this case, images. So with this in mind, now we can, or we have to go to the .vvm startup and here define in our resources here this part. Our module is called camera module, and the location, as we can see previously in the www root gs file or gs folder, sorry, and the site.gs, this part. But in this case, we have one dependencies here to use externally JavaScript model, for example, in this case, to take a picture, in this case, one library. And we can refer here as an other resource, in this case, with webcams.js, in other location, in this case in a local file, but also we can refer an external file in one in some web page. So in this part, we have this model, camera module, and with this dependence to use other JavaScript library. So in the other path, we can go to the default page in the .html part. And here we use the JS directive, specify the name of the model. As you can see here, camera module. And then the idea is the same. We can go to this part and have these two buttons, as we can see previously in our execution. The first button to call to take a snapshot functionality. We can personalize this control, for example, putting this text using some class. So this is one example. The other one is, for example, to have here to refresh our web page to, for example, when we upload one image, we can call to JavaScript a function here and update a snapshot. That is to update our web page and show the recently update image, as we can see here. And that's it, the idea of that we can use JS directive in this case to call with externally library here to take a picture, for example, and use an in our web application. Okay, and that's it that we can consider. Let me show you the last example in this case, not searching what image, but in this case, taking a picture to recognize some objects. For example, I have here this bottle of wine, and let me take this picture here. Okay. We can see here photo capture. And now, okay, we can use this refresh and then analyze this image. The object detected are this bottle and the face. And that's it, that a little example that we can see how to use this JS directive to have this type of demos to take pictures, search images, and do something like this. Now I'm going to show you another .vvm in action demo. Let me share it here. This other one is about translation of languages by text and speak. The idea is very, very similar. We can consider some services, some external services to use in our web applications, and also use JS directive to call some features in JavaScript. So in this case, the idea of this demo is, as a first point, by ourselves, speak to then have a text that is speak to text, and then translate this text to other language, and that text, that translated text, have the operation to text to speak. So this is the other demo, and the idea is very, very, very similar. In Azure, we can use some services, in this case, for the first one to translate text, and the other one to have speak services, to have the speak to text and text to speak. So this is from Azure, and now in our solution, in .NET solution, we can consider some library class to have that functionalities in Azure, and then in our web application, focus in called, in this case, audio JavaScript functionalities in JavaScript the idea is, for example, record our voice and then send that audio to our web application to have that process in this demo. So let me show you this example and then we can see the implementation. Okay, here we go with this, our DotVVM in action demo. So let me show you here. And the idea is that we can say something here for then transcript to text, translate that text, and have the voice of that translation. So I'm going to say something here. This is our DotVVM in action demo for this amazing event. This is our DotVVM in action demo for this amazing event. Okay, this functionality here to record our voices with calling JavaScript functionality, in this case, as you can see here from our .vvm web application. So I say that in English that we can translate it, for example, to Checo, for example. Let me translate it.
Toto je naše .dvm v akci demo pro tuto úžasnou událost.
Okay, I don't know if that's right, but our friends in Czech Republic can validate that. So this is the idea of this example. Also, we can see here this translated voice. We can use that with yes directive as well. So now we can see how is the implementation to use this. Okay, we are here, and now we can consider as the same logic as we can see previously. In the www root, we have here in resources one file called script.js, and here we have that class, this class to refer this model to have this functionality here. And the most important thing here is two parts. Start recording to start the recording of the voice, and then stop recording to have this file, the file of the recording. We can also consider this static part visualize to call or refer from our web application this graphic of our voice. And the most important part here is these two methods, start recording and stop recording. So we can go now to the .vvm startup part. As you can imagine here, we have the configure resources here, and we have this register to set up our audio model, in this case, with the JavaScript functionality, in this case, in the path resources / script yes, as you can see here. And now we can consider in our views, in this case, in our example, default.html, in this part, we have as a first point this visualizer, but this is externally of our JavaScript functionalities. This is externally of the library that use that functionality. But the important part here is these two buttons. To, as a first point, start recording with this invoke, and the other part, stop recording with this other invoke with JS directive. So this is the idea of this example, and we can consider see another test of this application to see in this moment. So let me share you. Okay, our application is here, and now we can consider the last example. Let me say something in this time in Spanish. Este evento está siendo súper increíble, lo estoy disfrutando bastante. Este evento está siendo súper increíble, lo estoy disfrutando bastante. Okay, now we can consider the input language, in this case is Spanish, and now we can translate it to English here. And okay, I'm going to translate.
This event is making it super incredible. I'm enjoying it quite a bit.
Yeah, that's right. So in this case, thank you for that. And that's it in this .vvm in action section in the .vvm Virtual Conference. I hope you really liked this presentation. So in this case, to learn how to use ES directive from .vvm to call some JavaScript functions, and also from JavaScript send some values to .vvm as well. So let me share again my screen here to say thank you very much. Gracias, merci de Cuyi. Namaste to everyone, because wow, it's really nice to participate in this type of spaces. And in .vvm Virtual Conference, there are many options that we can consider to create or modernize our web applications in an easy way. If you have any questions, comments, ideas, it will be a huge pleasure to be able to have in communication with you. You can find me in social networks as ES Daniel Gomez, or in my webpage as esdanielgomez.com, or you can write me for anything in daniel@esdanielgomez.com. So that's it in this case. So thank you very much, everyone. Again, I really hope that you like this presentation in our traditional .vvm in action sections. So I hope you enjoy this amazing .vvm Virtual Conference, and see you in the next occasion.
Thank you for staying with us for the last 2 days. I hope that you liked all the sessions. So this is a wrap. I just have one more slide with some links that you might find useful. So if you want to stay in touch with the .vvm team, if you want to ask us any questions, we are watching this Gitter chat we have on the first link. All the links will also appear in the description of the video, so you don't need to take screenshots or things like that. And also every fourth Thursday in every month, we are doing a regular community meetup. It's typically it's a 1 hour event streamed on Microsoft Teams, so you can join, you can ask any questions, and we are showing some demos or some interesting things which we are working on. So if you don't want to miss out these events, go to meetup.com/.vvm and RSVP there, so you will get some notifications and things like that. And also all the videos from this conference and also from our regular meetups will be published on our YouTube channel. So if you haven't subscribed yet, subscribe on the YouTube channel of .vvm, and you will get information about all our videos, and you will get notified when we publish some new content. We will post all the demos you have seen here on this conference in the description, so follow this video later to get links for all the repos. Right now we are publishing these things on our GitHub. So I hope that you have enjoyed this conference, and I hope that you will use .vvm and give us your feedback, because it's very important for us to see how you are using the framework, what features you like, what improvements you would like to have in the framework. So no matter if you have a new web application you want to write, or if you want to use .vvm for modernizing web forms apps and getting them to .NET 6, stay tuned and stay with us and give us your feedback. It's very important for us. So thank you and have a nice rest of the day.